We're at Anglian Water's Pine Wipe wastewater recycling facility, and we're here to look at the sludge treatment centre where we're using our Helea advanced digestion technology. This site has been operational for more than 10 years, and this is treating all of the sludge before it goes into our existing anaerobic digestion assets. Helea technology was originally developed by Anglian Water, and they identified that by re-engineering a biological hydrolysis process, they could come up with a better level of process safety, stability, robustness, and most importantly, maximising the energy we can recover from that sludge.
Helea is highly efficient pretreatment technology used to process the sludge prior to anaerobic digestion. More gas production can be achieved from the site, and because of the pasteurization process, you will get enhanced biosolids quality from your sludge. Helea is a simple three-stage process. The first stage is a heating stage where you heat up the sludge to 42 degrees, and then from there the sludge will pump to two parallel pasteurization tanks where the temperature is 55 degrees. And then from there it goes to the hydrolysis tank, which again the temperature drops to 42 degrees Celsius. And that is where all the breakdown of the organic matter happens and the energy of the sludge can be easily released in the downstream anaerobic digestion. The whole process is more energy efficient compared to the other competing technologies out there for advanced anaerobic digestion. It's a cost-efficient process.
On the marketplace, there wasn't a solution which gave us quite exactly what we wanted. So it was actually that exploration of what can we do better and how can we build this better, and having a partner like Royal Haskoning was key to that development. So a lot of the development was done alongside existing sludge treatment centre technologies, and what we were actually able to do is optimise the process of Helea for enhancing the biogas production and also the safety features of the plant. I think the key thing about being a water company and developing the technology has been being able to actually focus on what's important to the company rather than what's important to a technology developer. We weren't after commercial gain when we set this technology up, we were after getting the best performing plants that we could possibly achieve in Anglian Water. One of the things we've been doing over the last 10 years is optimise the throughput of the sites to really get the best out of the plants, but also minimising chemical usage and making sure that we get the right performance across the plant from a throughput, a cost, and also an odour and customer focus.
The raw thickened sludge, it goes to the heating tank where the tank is heated up to 42 degrees, and that heat is provided by the hot water circuit or the waste heat from the CHP engine. If the site doesn't have a CHP engine and they have a gas-to-grid facility, the site could opt for other alternative technologies such as heat pump to provide the heat for the site that is beneficial. Stage 2 is a pasteurization stage, which the sludge is heated up in two tanks working in parallel in a batch mode to 55 degrees. The batch-wise process prevents the short-circuiting and also cross-contamination, so this ensures that you will get the high-quality biosolids. The sludge passes through a steam injector, and this steam is supplied by exhaust gas heat recovery from the CHP engine. And when it reaches the 55 degrees, we hold the sludge for 5 hours to meet the regulatory compliance for the high standard and high quality sludge. For the site with the gas-to-grid, about 10% of the gas generated will be used for the stage 1 and 2 of the process. Or they can use other means of heat generation like a heat pump and those other alternatives. Stage 3 is hydrolysis, where the breakdown of the organic matter takes place. The temperature in the hydrolysis tank is around 42 degrees because the microorganisms need to work in a mesophilic range of temperature. The big innovation of Helea is trying to maintain and achieve the optimum retention time for the sludge in the hydrolysis tank. The main aim of the Helea is breakdown of the organic matter, but we do not want the sludge to have very long or very short retention time in the hydrolysis stage, because otherwise we don't get the benefit. However, by maintaining the levels in the tank to achieve that 2 days retention time, we could offer a stable process with 100% availability on the site.
So this site has been overproducing its design average throughput. The performance across Anglian water sites, the Helea, are far outperforming the other technologies. So on our other sites, Colchester, Cliff Key, we're seeing conversion rates in excess of 1 megawatt electrical per tonne dry solids. At Colchester, even for periods, we're seeing 1.1 megawatt electrical per tonne dry solids. The biggest benefits of Helea have been the dewaterability of the cake. We've been able to maximise biogas production and improve engine outputs, which also helps towards our carbon cost reduction programme. So by far the best performing plants in Anglian water.
So in the journey to net zero, we want to maximise the energy we can recover from sludge. We want a safe product we can recycle to agricultural land, and we want to do that in the most energy efficient and sustainable way possible. It's all about efficiency in terms of energy recovery. This process has the highest net energy yield, we believe, in the industry. We're letting the biology do the work to break these substances down so we can recover them as valuable biogas, and we minimise then the potential for release of harmful methane downstream.
The partnership with Haskoning's been brilliant, and I think we're now at a point where we're ready to sort of push this technology to market with Royal Haskoning.
The whole process is more energy efficient for advanced anaerobic digestion.
We're seeing conversion rates in excess of 1 megawatt electrical per tonne dry solids. The Helea are far outperforming the other technologies.
These have been their best performing sites, a state-of-the-art process. We're proud to take this technology to the wider water industry.